Join us on a journey with Helix, where innovation meets efficiency.
My starting point here is actually a completely vanilla install of Flightkit. So we provide Flightkit as a Deb package, as a Debian package. It's easy to install. There is a command that I'll show you that allows you to just set up a copy of the tutorials, and I'm going to use one of our provided tutorials to illustrate kind of the overall development flow. And in this case, I'm going to be demonstrating hardware interfacing. So we'll start off just by running up a deployment on a Raspberry Pi. I've got a Raspberry Pi here, and I will connect to it using Helix Lab, which is the graphical test software, and I'll show you some really basic interactions with that. And then what we'll do is we'll create a new software component. So plugged into the back of my Raspberry Pi, I have a really simple light sensor. It's just a simple light sensing chip, and it's interfaced over I2C. And so what we'll do is we'll go through the process of creating a component for that allows us to sense the light levels in where I am just now, and I'll show you that working. So the idea here is that I'm going to illustrate all of the major steps in the development workflow for developing with Flightkit. So right, I'm just going to kill that. So what I have here is I've got a console. I've created a directory where I'm just going to be doing some work in. And the first thing I'm going to do is ask Flightkit for a copy of the tutorial workspaces to start with. So there's a command that comes as part of Helix Flightkit. So all the Helix Flightkit commands start HFK. In here, there's a special command that just allows me to prepare the tutorials, and that has created some directories for me. So if I just go into those directories that's in the tutorials, we've got a set of tutorials around developing components, and the one that I'm going to show you today is the first hardware interaction demo and tutorial. So inside here, we have just this is a basic workspace. So this is a copy of the workspace, and this is the files that, for example, if you were going to commit this to version control, this is the files that you would commit. To set that workspace up and to be able to use it, there has to be a bunch of other files in there that are pulled out of dependency bundles and things like that. So what I can do is ask Flightkit to prepare this workspace for me, so it's ready to use. So I only need to do this once, and that's because I've got a fresh copy of this. So I'll just say, right, can I have a workspace? And please, can you prepare it for me? So it's going to prepare the workspace. This is a good illustration of the way that the tools work. They're hopefully very logical to follow. It's just the Flightkit tool, HFK, followed by the thing you're working on, followed by the action that you want to take. And hopefully you'll see that as we go through. So what I'm going to do then also is to pull that the workspace that we have and just prepare. I've got that open in VS Code, and so we can use this to explore what's inside this workspace. So we've got missions and the library here. The library is super simple. It's just got a deployment type in it. That's the only thing it has. And then it also has a mission, which actually has one deployment in it. So there's just one computer basically that we have modeled in this mission. And it is running one piece of software, and it's a very basic template for flight software. At the moment, there isn't any light sensor or anything in there, even though it's called light sensor demo, because that's what we're going to add to it. But in the meantime, what I'm going to do is just build that. So if I do HFK mission build, I can build this, and it's called hardware interaction 1. That's the name of the mission. And so it's going to sit there and pull in all of the necessary dependencies from the dependency bundles. It'll build those. it's also going to export the mission database for that. So at this point, I would transfer that over to the Raspberry Pi. The one thing that's been giving me grief just now is that the SCP, the copy to the Pi, is being really slow. So I've got a copy already on the Pi, and so I'm going to run that up. So if I think it was that one there. That's the flight software running on the Raspberry Pi. This is just an SSH connection to the Pi. So how do we talk to it? Well, I've got here, this is Helix Lab. This is effectively like our ground software. So what I'm going to do is I'm going to load the mission database into there. And so this just allows me to browse for the mission database. So I'm going to go into hardware interaction 1. So this is our workspace. You can see the library and missions folders. There's also an output folder. That's where the tooling has generated all of the output. So that is both the binary and also the mission database itself. So this mission, there's the mission database for it. I'm going to Helix Lab is going to load that. It will know some information about the system. It's going to know what the kind of physical computer is in the system, what you can connect to, and it's going to know some information about the functionality that's available in that software image. So I'm going to try and connect to that. This is on my network So I'm just going to connect to that. And so we've got a TCP connection to it. So this TCP connection is essentially a standard space link. So the packets that are flowing over this are CCSTS space packets. So this is fully representative of a typical space ground connection. What we have in here is essentially a way for us to explore the model. So within the kind of Linux process that we're working with, we've got this demo deployment. And the demo deployment has some components in it. One of them here is a software component. It's a really simple software component. It provides access to telemetry parameters that have fixed values, and they allow us to get access to version information. So one of the things in here is the version. This is a telemetry parameter. And you can see that as I bring this up, as I click on this, there's some documentation associated to it. It's not very exciting documentation, but this documentation is all captured in the model. And so the model information is not just about the functional system, but also about how to use it. So we can do a get operation, and so we get a value back. So what's happening under the hood is that it's sending telemetry, sending telecommand packets to the Raspberry Pi, which is running this software. Those are an encoding of a service operation, which is a parameter service operation, and then we get telemetry packets back. Those get decoded and they get provided. And so we're doing quite a high-level operation that's getting turned into low-level packets, and the Helix Lab is handling that for us. And in the flight software itself, we can actually see that, for example, in the comms section, we have, for example, a space packet component sitting in there. And that's because space packets are being used as part of the communication stack that's allowing us to talk to this in the first place. So that's us working with the flight system. What I'm going to do is to just disconnect from that, particularly in case I confuse myself at any point. So let's go back to the code environment. I'm just going to kill that flight software, and we will just go back to our console. What we're going to do now is create a new software component for the light sensor that I have plugged in to the Raspberry Pi. So I'm going to do HFK component type, because I'm going to create a new component type, and I'm going to name it after the type of light sensor that I have. So it's actually the name of the chip that's on there. So it's the snappily named BH1750 FVI. So that's what I'm going to call it. That's a pretty simple operation because all that really does is it creates a component type XML file, which is a description of the component type. So I'm going to just show you in here. In the library, we now have component types. We've got subsist, BH1750 FEI, and we have a component type. So this is where we tell the system what the interface to this component will be. And so this is done in terms of things like parameters, which is what we were working with on the version component. So let's get some stuff into here. Now, the first thing that we usually include in here is some information, just some helpful documentation. This ends up in the model, as I said, and it just tells people, whether those be developers or operators, about the software component. So I'm just going to drop that in there so that you don't have to watch me type that really badly. But there's just two tags in here. There's just a short description of this component and then some documentation. The next thing we need to do is talk about how this component is going to get access to the light sensor. And this is done using one of our standard services. The standard service that we use is called the Memory Access Service, so MAS, Memory Access Service. And it sounds like it's always to do with memory, but actually it just represents any situation where the service is needing to do reading and writing to an item. And in this case, the item is a I2C peripheral. So the underlying I2C bus itself provides generic access to the I2C bus using the memory access service. And so that's what we are going to depend on. So there aren't global APIs in Flightkit. There's no kind of I2C API. Instead, we say that this component actually depends on this kind of service. And then when you come to create your system, you get to choose what that's connected to. And effectively what happens on the code for this little component is that we get like our very own personal API for accessing that service, and the generated code connects that up for the given deployment. So in here, we're going to add in some services, or in this specific case, we've got a service requirement, the fact that we require a service in order to be able to work. And the type of the service, as I mentioned, is the memory access service. And yeah, we get to give it a name. I'm going to call this bus because this is basically access to the underlying I2C bus. And so I'm just going to note that. So access to the I2C bus that has the light sensor on it. There we go. That helps document what it is that we're doing. So the final thing we're going to do is provide something from this component, and we're going to provide a parameter that represents the light level. So we're going to add a single telemetry parameter. I'm going to call it light because it's the light level, and this is a read-only parameter. So, oops, sorry. It's a read-only parameter, and again, I'm going to provide a wee bit of documentation and just say, so this the sensed light level in lux, because that's what the sensor provides. Well, it will provide that after we convert it, and we need to tell it what the type of this telemetry parameter is. The type of this telemetry parameter in this case is an integer. I want it to be a 16-bit integer, and I also want it to be unsigned. So it signed is false. That is a complete description of the interface to our light sensor component. So now we need to implement it. The next thing we do is we ask Flightkit to create us the skeleton code for us to implement that. So I do HFK component type generate. So this is going to generate a skeleton, and then I need to give it the name of my component, all over again, and it goes away and it generates me some code. So if we go back to our IDE, you can see there's some new stuff in here. The main thing is this C file. So this C file is the implementation for our component type. It's actually fairly simple. So there are three functions in here. There is an initialization function, and this is basically like a constructor if you want to think about this in object-oriented code, object-oriented terms. And so that initialization, the bit of generated code here just does a little bit of setup. One of the things it sets up is some stuff that you probably want. You don't have to use, but you probably want. So it's giving it to you just to be helpful. The thing it's giving us is a mutex actually, to help us protect access to our telemetry parameter. And then this function here is the opposite. This is our finalization function, like a destructor. So that's for when the system shuts down. And here is where the excitement is. This is our parameter accessor. So this is for the light parameter. So what we need to do is we need to implement this. I've got a code snippet here that will allow me to just drop that in. So I'm going to just select that and replace it. Just to quickly talk you through what this code does. So it's pretty simple. We've got a mutual exclusion section here, as I mentioned, and then really we just have two I2C operations. We are writing to the I2C bus, and then we just wait for a little period of time, and then we read from the I2C bus, and we get the bytes back from the I2C bus. We turn them into a number, we convert it according to the calibration equation, and then we return that. So that's what this code is doing. You'll notice that these I2C operations, the name of them starts with the name of the component type. And that is because that's the kind of our own personal API that I was talking about. So exactly what that ends up calling in the system is not our call as the developer of this component type. It's the call of whoever then puts this into a deployment and connects it up. So one of the operations in here is this operation, which is one of the things in our utility libraries. It's just to do an endianness conversion. Because that's in a library that isn't already included, I'm just going to bang the hash include for that in there before I forget. So util h. So there we go. That's our code implemented. That's everything that we need to do. So we have a new component type in the library. It's implemented. The next thing we want to do is add it to our blueprint for our deployment. So a deployment type basically just describes the components it's made of and how they're connected together. So it might be a bit difficult to read. This is probably a bit of a wall of XML, so I apologize for that. But here, for example, that's the version component. Remember the one that we got the version information from? That's it. And that's just instantiating the version component. All this other stuff is actually the communication stack. So what I want to do is to add the components that we need to access our light sensor. The first of those is that we need a component to represent the I2C interface itself. And this is effectively the I2C controller, the I2C peripheral. So we need a component. The type of that component, it comes from our standard libraries. So in this case, it's the Linux driver access for the I2C bus. And so there we go. So it's the I2C controller. I'm going to call that component. So that's the type of thing we're instantiating. I'm going to call it BSC because on the Raspberry Pi, it's the Broadcom serial component. And so that's why I've called it that. So that's it. That's us having included the I2C controller. We will need to configure that in a moment, but I'll show you that separately. The next thing I'm going to do is add in a component for the light sensor itself. So we've just created this, that it's the component type we've just created. And I'm going to just call that light sensor because that's what it is. If you remember, that had a service requirement. It was required it's required that that is connected up to a provider of the memory access service. If we don't make that connection, the build will fail and you'll get an error message saying you haven't connected that up. So I'm going to do that. I'm going to create connection. It's a service connection in this case. And so I need to connect up to the BSC component. And the BSC component provides its memory access service. It calls it on its end data, and we called it bus. And so that's making a connection there between the light sensor and the I2C controller. So that's us having described that deployment type. So we modified the deployment type. It's being used within our mission. So the next thing I need to do is I need to regenerate the mission code. So HFK mission generate, and this is the hardware interaction one mission. So the reason I'm doing this is because the configuration of each of these components is actually done in C code. And what I've done there is generate the skeleton code for that configuration. It's very simple. The one that we need to configure is the I2C controller. And what we need to do is provide it with the information that it needs to know what the I2C address is for that particular connection that we've made. And so this snippet of code here, you'll see there's no actual executable code here. It's just data, it's the configuration information. And we're setting the peripheral address here. Just that's the I2C address of the light sensor on the I2C bus. So we're done for creating this. Now we need to build it. So we do it just like with the mission generate. We're going to repeat what we did earlier actually, and build this mission. That's we're going to go away and build that. One of the things it does is it regenerates the spacecraft database for that. And so yeah, I'll just set the copy going, and then we'll get we'll open the mission database again. So that's the mission database. The mission database. And in the meantime, that we have just executed. I'm just going to make sure I'm running the right one. So we can reconnect to that, and we'll go to commanding. So what you'll see, because we have reloaded the mission database, it now has our new components in it. So it has the I2C controller, and it has the light sensor. I'm really hoping I've run the right flight software image. Yes, I have. Good, that's the one that we've just built. And that is giving us back a light level as a telemetry parameter. And I'm going to try and shine a bit of a light on the light sensor. And oh, look, it's gone up a little bit. And that's because it's got a bit more ambient light. And so that is changing with the light levels that we're getting. And hopefully if I turn the light off again, then that goes back down again. So that is pretty much a complete tour through the development process. But we have really only scratched the surface in terms of what of the power of what Flightkit can do, and how much you can do, and how quickly you can do that for developing your particular systems. So to kind of wrap up a bit, let's see if I can bring this back again.